Okay, I gotta record this and then share computer sound. Okay, so this is good. All right. All right, so this is test number 2. This is also your lab 2. Okay, we did this last week, right? You guys did this in groups, correct? All right, just give me a verification on that. Yes or no? Okay, so you guys remember doing it because I didn't get a chance to grade again. All right. So we get a ball thrown up. Ball is thrown in the upper direction, right? So I throw the ball in the upper direction, and you notice that it comes to a momentary stop. You throw it in the upper direction, it goes up, and then comes to the stop right here somewhere. Goes up, comes to the stop. You throw it up, it comes to the stop at some point. All right, is the ball accelerated at the moment that it stops? Okay, your common sense will say no. Your common sense is going to say no, it's not, because it's not moving. If it's not moving, it's not accelerating. Okay, so if that's the way you answered it, I'm going to give you 0.25 for writing something. Okay, that's not the right answer. That's the wrong answer. All right, let's go over the correct answers, and I'm going to give you some point percentages regarding that, points regarding it. Some of you guys say, yeah, it's accelerating because of gravity. It's free fall. It's always accelerating once the ball leaves your hand because of gravity. That's it. Oh, so what is that worth? I would say out of 2 points, that's probably worth 1 point in terms of grading, which means that the statement is still incomplete. All right, you're just using a definition to answer a question that kind of lacks understanding. What is acceleration? And does this fit into the definition of acceleration? Okay, guys, what's acceleration? Acceleration is how fast the velocity changes in time. So the two things change within that time period. The speed changes and the direction changes. About a second before it stops, it's moving. It goes from 10 to 0. That's acceleration. About a second later, it goes from 0 to 10. That's also acceleration. Acceleration is how fast the velocity changes in time. If it's moving before it stops, and if it's moving after it stops, it's always accelerating. That's what it means. If it's moving a trillionth of a second before it stops, it's accelerating. If it's moving a quadrillionth of a second after it stops, it's still accelerating. You can have one of your instantaneous speeds to be 0 in acceleration. Right? It doesn't mean that it's not moving. It's not like a bus stop. It doesn't stop and stay there. It doesn't come to a stop and stay there. It's part of motion. Not to mention also the direction is changing. So the correct answer is it's accelerating. It's accelerating because it's moving before it stops and after it stops. All right. Just because speed is 0 at some point doesn't mean that the acceleration is 0. Acceleration is how fast that speed changes. Acceleration is how fast that velocity changes. All right. So that's the correct answer. Okay. So I'm going to give you 5 points for your comment. Right or wrong, I want you guys to just express it so I know that we're connecting. All right. So Victor said, yeah, it's 10 meters per second squared. Correct. But justification is what we were going for.
So okay. The acceleration would be constant from initial point to when it dropped back, like a free fall?
Absolutely. Once the ball leaves your hand. Once the ball leaves your hand. As soon as gravity takes over, it's constant. That's it. Once it leaves your hand, it's constant. But answering it like that will only get you 1 point. So I'm still looking for a justification. All right, so what else do we have? Oh, okay, yeah, question number 2. So which ball accelerates more rapidly?
I'm sorry, I just 1 point. For the first question, so because of the velocity, the change in direction, that's why that would be the justification for the first question.
Right, but it's not, that's justification is related to it, but obviously I'm looking for a concise explanation, which is just say that it fits into the definition of acceleration, right? Which is change in speed. Meaning that it's moving before it stops and after it stops. So now that's a complete explanation right there. Okay, so I'm going to give you 5 more points. Okay, ask for clarifications. This is good. This is good because I'm going to pick 2 out of these 5 questions for your upgrade. So I'm recording it right now, so I'm going to edit it and put it online today. Excuse me, tonight. So you can go back and listen to it. But once the test becomes available, video is not going to be available at that point. So study this. All right, question number 2. So which ball accelerates more rapidly? The one that's dropped, the other one thrown down with an initial speed of 30 miles per hour. So we got 2 balls. One of them you drop, the other one you throw, right? Which one is going to accelerate more rapidly? This one or this one? This one or this one? Okay, notice that this is, your mind says, oh, or Rosanna said both of them have the same acceleration. But your common sense will say this one is accelerating more rapidly, not this one. And Rosanna is right. Acceleration is not how fast it's falling, it's how fast it's speeding up. So which means that which one is going to speed up more rapidly? Guys, the one that you dropped literally is going to go from 0 to 10 within the single second. The one that you throw, what that 30 miles per hour is, let's make 30 meters per second. It's going to go from 30 meters per second to 40 meters per second the next second. So both of them are going to speed up at the same rate, which means that both of them are going to have the same acceleration. Because the motion is occurring under the influence of gravity, which means that gravity is going to have the same effect on all falling objects. All right, so I just covered everything from every single perspective imaginable because I'm trying to get full credit here. So the short answer is, which one is going to accelerate more rapidly, this one or that one? Rosanna said both of them are the same. That's correct. So that's worth like 1 point. Now the justification. The justification is all objects will accelerate under the influence of gravity at the same rate. So the gravity is going to have the same effect on all falling objects. So everything is going to speed up at the same rate. Now that's a complete explanation. That explanation is worth 2 points, 2 out of 2. Moving on, question number 3. Question number 3. What do we do with the question number 3? Okay, let me make this a little bit larger maybe. Okay. Question number 3. It's about NASA. How does NASA make motion predictable? Okay, the short answer is they eliminate jerk by making acceleration constant. What is that worth? What is that worth? It's worth only 1 point. Okay, so which means that we're lacking something. So let's talk about predictable motion. What is predictable motion? Predictable motion, when the motion becomes predictable, 2 things about that motion will become predictable. Location becomes predictable at any given point in time. Guys, if you know the time, you know the location. So location becomes predictable. What else? Speed at that location and at that time becomes predictable. All right, so the location becomes predictable at any given point in time. If you know the time, you know the location. You also know the speed at that time and at that location. All right, that's the full answer. So NASA makes motion predictable by fixing the acceleration, which means that they eliminate jerk. It means the same thing. So that the location at any given point in time becomes predictable and speed at that location at that time become predictable. That's predictable motion. Question number 4. All right, this is a factual statement about cats. This is known as the high-rise syndrome. It says any cat falling higher than 70 feet more likely to survive the impact with less severe injuries. All right, so you got a cat falling from the 8th floor, 10th floor, 20th floor of a building. Anything above 70 feet, more likely to be survivable with less severe injuries. All right, so this is known as the high-rise syndrome. Okay, so we didn't discuss the main reason for cat survival. We're talking about surviving impact, obviously. But we discussed the secondary reason. Okay, so what is the secondary reason for the cats to be able to survive a fall, any fall larger than 70 feet? Or any fall for that matter. It doesn't really matter. Most cats will survive just about any fall, except the injuries tend to be less severe if it's more than 70 feet. Okay, guys, it's the secondary reason. Mario says 9 lives. I think the idea of 9 lives, Jordan says air resistance and mass. Okay, I'm going to give you both of you guys 5 points. The reason that we discuss in class is the reason why for anything or anyone to survive impact. Okay, so Garcia said extra shoulder muscles. Give yourself 10 points. Is because the cats are so much better. They're so much better at absorbing impact. So what that means is because they're able to increase the impact time. They can increase the impact time by because they got extra shoulder muscles. Okay, very good. That's actually correct. They're able to increase the impact time because they do have extra muscles in their hind legs as well as shoulders. That's able to increase the impact time. That reduces the acceleration. All right, I kind of messed that up. All right, so the cats are better at absorbing impact because of the extra muscles that they have. And with those extra muscles, they can actually increase the impact time. By increasing the impact time, they automatically, that means that the acceleration is reduced automatically. So the impact time goes up, the acceleration goes down, and then it becomes survivable. All right, so they're designed that way, the cats. Survival of the fittest, I think. That's the secondary reason. That's not the primary reason. Okay. Okay, Rosanna, absolutely give yourself 10 points for that one. Okay, so you came up with a complete explanation. Now, that explanation alone is worth 2 points on the task. All right, the main reason is because they're able to increase the impact time. When you increase the impact time, all right, ignore the higher surface area, this and that. I don't care about that. Just focus on the impact time. 3 extra muscles will increase the impact time, thereby reducing the acceleration. So it makes it more survivable. All right, so that's the complete explanation. So that's what I was looking for. Last question. We got a jump from a bridge lasting for 5 seconds. Remember that 5-second drop? The guy was jumping from a bridge, and then he hit water with 112 mile per hour impact speed. So his impact speed was 112 miles per hour. This guy's impact speed was 112 miles per hour. So the question is that survivable? Okay, so it's not how fast you hit water. It's how fast you come to a stop. It's not your final speed. It's your acceleration. Your acceleration is what determines whether you live or die. All right. Hitting water is not like hitting concrete. Water is going to give. If you're feeling anything, you will feel like you're hitting concrete. If you're feeling like you're hitting concrete, that means that you got like 1/10 of a second impact time. With 1/10 of a second impact time, your acceleration would be about 50 Gs. All right. Given the fact that you can survive up to 140, it's a survivable range. But anything over 25, you're in the bone breaking region. So which means that you will end up breaking bones. I mean, it's possible that you can break your neck and die from it. Okay, so that's the scenario that you cannot really dismiss. But more than likely, barring breaking your neck, you will be able to survive the impact with broken bones. So the initial impact is survivable in this case. Of course, you're going to have broken bones, internal bleeding. You're going to go in and out of consciousness. If no one sees you fall, chances are no one is going to come to your rescue. So you can't survive under those circumstances on your own. It's out of the question. But the initial impact will be survivable. All right, so I gave you guys the long version of a short answer.
So the initial impact would be survivable. Is it because what if he lands like flat on the water?
Yeah, the worst case. Okay, Khan, I'm gonna give you 5 points because you're making a really good point. The worst case scenario is survivable, which is landing flat on your back, on your belly, or whatever. Impact time is gonna be way too short. But water still gives, so your impact time is gonna be around 1/10 of a second. Your acceleration is gonna be around 50 Gs. You will break bones. You're still within a bone breaking region of the G load, the acceleration. And unless you break your neck, it's survivable. Initial impact is survivable. In the best case scenario, landing on your, if you hit the water with your feet first, head first, or whatnot, your impact time is going to be about a second long. So that's easily survivable. It's like, I don't know, it's like 5 Gs or less than that. So
is it survivable because of the surface tension, whatever area, because it's not concrete, it's water?
That's okay. So you're making a good point. Because it's not concrete, it gives. It's going to give. Water gives. All right, so it gives enough to create a large enough impact time, usually, depending upon your speed. You don't want to be hitting water at 500 miles per hour, so that's not going to happen. Faster you go, the shorter the impact time is. But it's not like concrete. Water gives, the concrete doesn't. So that's the difference. All right, let's get back. I come up with a shorter answer because I've been just rambling all over the place. So jump from a bridge lasting for 5 seconds. We'll land with 112 mile per hour impact speed. So which means that you're hitting water at 112 miles per hour speed. Your speed is 112 at the time you hit the water. Is the impact survivable? The answer to that question is depends on the acceleration. All right, so, and depends on how you hit the water. Worst case scenario is survivable, so it's the best case scenario. Worst case scenario, landing on your back, on your belly or whatever. Impact time is going to be relatively short. It's about 1/10 of a second, so acceleration is about 50 Gs. For a fraction of a second, you can survive up to 140, so you expect the person to be able to survive with broken bones. If the person hits the water with feet first or head first, once again, what do you expect? All right, it's easily survivable if that's the case because it's going to be less than 5 Gs. So that's what I'm looking for. All right. Oh, man, this is good. Okay, so I'm going to stop this.